Question 6, Part C. A farmer accidentally spread a dangerous chemical on a paddock. The concentration of the chemical in the soil was initially measured at 5 kilograms per hectare. 1 year later, the concentration was found to be 2.8 kilograms per hectare. It is known that the concentration, C, is given by C equals C0 times e to the power of negative kt, where C0 and k are constants and t is measured in years. Part 1. Evaluate C0 and k. Consider the initial condition. When t equals 0, c equals 5. Given the model, c equals C0 times e to the power of negative kt. So substituting 5 for c and 0 for t in the model, we get the equation 5 equals C0 times e to the power of negative k times 0. Now, negative k times 0, of course, is 0, and we have e to the power of 0. Recall that e to the power of 0 equals 1. So the equation simplifies to 5 equals C0 times 1. So C0 is equal to 5. Now, when t equals 1, c is equal to 2.8. Substituting 1 for t and 2.8 for c in the model, and we have the value of C0, which is 5, we get the equation 2.8 equals 5 times e to the power of negative k times 1. Now, negative k times 1 is negative k, and dividing 2.8 by 5, we get 0.56 equals e to the power of negative k. Taking the natural logarithm of both sides, to undo this operation here, the operation of raising e to the power of negative k, we get ln of 0.56 equals ln of e to the power of negative k. Now the ln and the e will cancel. We have ln of 0.56 equals negative k. So making k the subject, we get k equals negative ln of 0.56, which evaluates to 0.5798184953, which rounds to 0.5798, correct to 4 significant figures. Therefore, C0 equals 5 and k equals 0.5798. Part 2. It is safe to use the paddock when the concentration is below 0.2 kilograms per hectare. How long must the farmer wait after the accident before the paddock can be used? Give your answer in years, correct to 1 decimal place. We want to find the value of t such that c is less than 0.2. So we can set up an inequality, 5 times e to the power of negative 0.5798t less than 0.2. Dividing 0.2 by 5, we get e to the power of negative 0.5798t less than 0.04. Taking the natural logarithm of both sides of the inequality, we get ln of e to the power of negative 0.5798t less than ln of 0.04. Now the ln and the e will cancel, so we have negative 0.5798t less than ln of 0.04. Dividing the right-hand side by negative 0.5798 to isolate the t, we also have to flip the inequality symbol because we're dividing by a negative number. We get t is greater than ln of 0.04 divided by negative 0.5798. And evaluating the right-hand side of the inequality, we get t is greater than 5.5517 and so on. Interpreting this result, we get the farmer must wait at least 5.6 years before the paddock can be used, correct to 1 decimal place.